So between the last video and this video, I've added ports to the other side, and now I have my full screen, at least all the stuff I care about. Now, I'm not sure if it's perfect, but once I do my test print, I'll know if there's any fitment change I have to make. So our next step is to build an assembly. So I'm going to take and create an assembly. And I'm going to place one laptop screen. And I should probably save my other thing, which has been really brave not saving it because it's been a day or two since I last worked. I'm going to call this USB-C screen because it's powered off USB-C or Lightning or Thunderbolt technically. Now I'm going to place the Thunderbolt screen in place, or USB-C screen in place. And I'm going to base everything on the laptop screen. So I'm going to make him the ground, except I'm not going to ground him until I set his orientation because I don't have my laptop typically perfectly 90 degrees. I tend to have it rocked back about 15, 20 degrees. I don't know exactly how much, so I'm going to set that. So I'm going to actually mate this to the universal origin of the assembly. So I'm going to start off by mating the axis of this hinge to the y-axis or x-axis of the thing. Now, if I take and move this can tilt back and forth. I also want to constrain, I'm going to use the laptop screen's YZ plane and map that to the YZ plane of the assembly. Change direction so it points the right way. Now, my laptop screen can tilt back and forth. Now I'm going to set an angle. I'm going to go hit the right. I'm going to constrain the front of the screen at an angle to the XY plane. And I'm going to look at it from the right. And I'm going to go, 15 degrees. And that'd be negative apparently because I don't want it closed. Maybe 10 degrees. That looks probably close. I'm not sure. Once I get the thing and I put things together, I'll be happier with it. But that's a starting point. So now I have my screen in place. Now let's start mounting the other screen. So again, I'm going to use I am going to ground him so that he's locked in place, even though he can't move anyway. I'm now going to constrain this guy's YZ plane to the laptop's YZ plane. And I want to switch direction. That looks right. And I'm going to move him so he's not floating in space because that looks weird. And I'm going to start off by doing this. I think I want this guy pretty much straight up and down. So I'm going to take and set an angle constraint between the top of this guy and the global XZ plane. But I'm going to offset it by some value to get this high enough. So let's try 10 inches, or rather negative 10 inches. Okay, let's go 18 inches. That's probably a little high. So let's go 17 inches. That looks good right now. We can always adjust it in a little bit. And now I'm going to take this guy and I'm going to turn it and start looking at that. I could probably set him lower, so I'm going to go to 17. And we're going to go negative 16.5. And I'm going to see to make sure I'm not hiding any of my screen. That looks really good. If I look at this from 3/4 view, I'm not blocking my screen at all, but that looks good. And now the last thing I'm going to do is I'm going to constrain and mate that surface to the top edge of this screen with a small offset, 0.1. That way there's space between these two guys, but they're fairly close together. Now, if I'm looking at that from my screen, it would look like that. From the side, it looks like that. Now, we are going to have to see about balance issues, and that's going to take some doing massing and stuff. So right now, I don't worry about tipping it backwards. We can adjust that as need be, but now I have the two screens physically kind of how I want them oriented. Next step is going to be building a piece to hold those together, and that's going to let us test all of our measurements to make sure we're actually on track. So I'm going to save this as full as both screens. And I will end this video here.